Hello my good friends. So welcome back to the lab. So today I have a bit of bad news, and the bad news is that for close to 3 days I have not been listening to some good music, and the reason behind that is my home theater system just died on me. So for today's video we are going to do an attempt to solve that issue, and since we have some skills on working on these things, let's get on with it. So I really don't think we are going to do an attempt, but rather we are going to solve the issue. So the unit I've been using is a Sony. So I don't know whether you can see it. So this is a Sony DZ650 home theater, and this is the receiver. So this is the thing. This is how it looks. We have your speaker ports there, your inputs and outputs there, and let me connect it, and I'll show you what the issue is. I think now we are good. So I'll switch it on. So I will switch it on. So you see there. Then I will connect this speaker. And then you can put some good music from this USB. And then I'll crank the volume all the way up. So see, the volume is at max. What? Wait a minute. I think I have another issue with the display. Something just happened. I swear this was not there. Something wrong is going on with the display. Maybe also that needs to be checked. So the issue I'm having with this is that all the other functions are working well. You can change the EQ. Right now this thing is supposed to be super loud, but this is the only sound I'm getting. Very low. So today we are going to be fixing this issue. Since all the other functions are working well, I think this one is supposed to be a straightforward repair. Also, I think if I fail to repair this, I have a backup here. There is no way I'm going to stay without music, so maybe I'll attempt to revive this. That is a story for another day. So that is the issue I'm having. Low sound level on this day. We are at max volume, and that's all what I get. Well, let's head to the bench and do this repair. Well, we are at the bench. I need to open this thing up. So we have a couple of screws that we need to attend to. So this, we need to attend to this, and two on the side, so one on each side. So let me set the camera very quick. We can get on with this. So this is an old model. Most of the functions are in one circuit board. So you have your receiver and the amplifier section in one circuit board. So hopefully nothing is wrong with the motherboard, but we can tell that the motherboard is okay, since the main board is okay, since all the other functions are working. So this is how the unit looks inside. I swear I saw some cockroaches somewhere. So you know the issue with cockroaches, they like staying in places where they are not supposed to. So especially inside these electronics, because of the warmth, so they like hiding in here. So let's do a rundown on this. So this is your power supply. So the power supply looks like this, and there is your main board. As I have said, every function is on this board apart from the power supply. So this is the amplifier section, and right after doing some visual inspection, I think we have some pregnant capacitors, and by pregnant capacitors, they are bulging. So I don't know whether you can tell. So all these capacitors, 4 of them, they are bulging at the top. I need to get some of these capacitors. So these are, I think, 470 microfarad by 50 volts. Yeah, those one are easy to find in the shop. So nothing there. So this is a heatsink for our class D amplifier chips, and for us to do this diagnostic, I need to switch the unit on, then have the speaker. So I'll need to use the speaker there. So the fan noise that you are hearing is from my power supply that is powering my LED, my lights. So you can ignore that. So the speaker is there. So I need to power the unit on. Let's give it some power. So I don't know what happened to the display here. This one is messing up with my head. I don't know whether you can tell. Some part of the display stays on. So I think we shall look at that. So let me put on some music. I'm suspecting I have an issue with the power supply, as we shall see. So if I go to my MP3 there, the volume is all the way up. So that issue is across all the channels. This is a 5.1 channel receiver, so meaning we have 5 channels for the mids and 1 for the bass or the subwoofer. So this is our power supply, and guys, here we are operating with live components. So this is the dangerous part of this power supply, so don't go poking your hands around here. So this is the heatsink for the main switching transistors. So I need to do some tests on this power supply, and so let's zoom in. So this is the connector, and there are some markings there, the voltages. So we have the VCC here. I'll come with a meter and maybe switch. Let's get the set it to DC. So I need to find some good ground. Let's first check whether the chassis is grounded. Yeah, so this body is grounded, so I just need to probe. Now I want to see whether I have all the voltages. The voltages I'm checking for are, we should have the always on 3.3 volts. Then we have the 5 volts, 12 volts and 32 volts. So I don't know whether you can see the 3.3 volts is there. Let me probe there, right there. I need to so, and I'm getting 3.4 volts there. So it's supposed to be 3.3, but a 0.1 volt increase, I think it's no problem. Yeah, it's around there, so that one is right. So the other voltage I need to check for is the, so let me check for 5 volts. Yeah, there we have it, 5 volts. So our 5 volts is present. So what else do we need to check? And the other supply we need to check is the 12 volts. And your 12 volts is there. It's a little bit high, but I think that one is good. And now let's check for the main voltage for the amplifier section, and that's supposed to be 32 volts. And check what I'm getting there. So I'm getting 0.8 in place of 32 volts. There we have our problem. So everything else is working correctly, but we have an issue with our main or the bigger power supply voltage. So this is how this power supply is divided. So right here, this section with this transformer. So this is our standby power supply, and this is our standby power supply switching MOSFET there. So this section is working all right since we have the standby voltages, and this section is always on. That's why you can switch this unit off using your remote, and also you can switch it back on using your remote. So we need some constant supply to the unit, and that supply is always 3.3 volts. So our always on voltage here is the 3.3 volts. So still on this standby power supply, we have our main 5 volts, and I think our 5 volts will be provided by this big diode here. So we have a diode here, so that one is for the 5 volts supply, and we also have some 12 volts supply somewhere. So these two voltages will come on together with the main voltage here when we switch the unit on. Now for this section where we have the bigger transformer, and 2 switching MOSFETs. This is our main voltage for the amplifier section. So the standby voltage will feed all the other low voltage components. All these chips you see here are low voltage, so they work between 3.3 and 5 volts. So all these chips are for the low voltage, but when it comes to the amplifier section, we need some higher voltage so that we can push that much power to our speakers. So that's where this big transformer comes in, and we have 2 switching MOSFETs for the main transformer here, and we have this smaller transformer. So this smaller transformer is our gate drive, so we need to create some isolation between the secondary side and the primary side, and that is done by this. So we switch our MOSFETs through this transformer, and I can see some transistors there for switching this transformer. And also we have our oscillator here, or our driver, the driving IC. So this IC is 7500. Yeah, this works the same as the famous TL494 IC, and upon switching on the unit, this IC will be fed, or this circuit here, the driving circuit here, will be fed by this small transistor here. We have a small transistor here, so it will feed 12 volts to this circuit here, so that we can start oscillating and driving our MOSFETs. The issue I'm thinking about is around this circuit here, the circuit around the main, the bigger 32 volts power supply. But first thing first, we switch it off and we remove it. So don't do this at home if you don't know what you are doing. The power supply is off, so I think we also need to clean this thing. Cockroaches have been doing their thing inside here, so I don't need the rest of the unit. We keep this away, so we are going to be focusing on this. You can see how the power supply is isolated here. We have the lower voltage non-dangerous side, and we have the higher voltage primary side, which can electrocute you. So I need to power this thing on, and right here we have our on and off switch. So I need to, right before we switch it on, we need to test the voltages again. So ground, this is our ground. We have 3.3 volts present. We have our 12 volts not there. This is 5 volts not there. Our main VCC, which is supposed to be 32 volts, not there. So we need to switch this thing on by shorting these 2 pins. So after shorting those 2 pins, we should have our 12 volts now, yeah, right about there, and also we should have our 5 volts present, so that's good. But when it comes to this, we are getting 8 volts, so 8.1 volts. So there is our problem. So our problem is we are going to be focusing around this area. So this is where we have the circuit for the main 32 volts power supply. So it's being fed by, I think we also have a MOSFET here. So this MOSFET gives that one is for 5 volts. Let's see whether this IC is getting power. It will get its power from this transistor here. Let's see whether we have at this pin, this is where we are supposed to have 12 volts, and you see we don't have 12 volts there, meaning this circuit is not on. So we get our 12 volt from this transistor here. See these three leads. These three leads are for our transistor. Let's see whether we have voltage there. So at the emitter of this transistor we have 12 volts, and at the base we have around 10 volts. At the collector we have 12 volts. So this transistor is working correctly. But when we come to this rail here, the one that is supposed to give the IC 12 volts, we have nothing. So meaning we have a discontinued circuit around here. If you take a closer look, so I don't know how this happened, but you can see here we have this pin is not connected. So it looks like someone has worked on this power supply before, and maybe they didn't make a proper solder joint around this place. So with the time they just got detached, and now we can't get the power supply to turn on. So let's deal with this and see whether we are going to have the power supply working. I remove some of this mask, solder mask. Maybe we can bend this pin in this direction. Now let's see whether we have a good connection there. So our connection is there, and we don't have a short between these pins. So let's turn the power supply on and see whether it will work. So our 3.3 is there. We short these two pins, and then yeah, the power supply is on. We test around this place. Now we have 12 volts, and yeah, right now our IC is being supplied with 12 volts, around 12 volts. So if we now come to this supply here, we can clearly see that we have our 32 volts back. So our 32 volts supply is back. So we have 32 there, we have 5 volts there, we have 12 volts and 3.3. so this power supply is supposed to be back online. let me come with the rest of the machine, and we put the power supply back. So I'm going to test, and then if it works, of course I know it will work because we have got our voltage back. Then I'll continue to do the cleanup, so because this thing needs to be cleaned. So the system is on, and let's insert a USB there. So I'll come with the remote and I choose some music. So let's do the volume. I've connected the speaker. So this is I have also connected the bass speaker, and the speaker I'm using for the bass or the subwoofer is this one. It's a bit overkill, but that amplifier can handle up to 3 ohms, and this is this is a double coil, so you can connect it in either 2 ohms or 8 ohms. Right now I have connected in series, so it is in 8 ohms configuration. So if you know about Ohm's law, the amplifier can handle that really well, since it's 8 ohm, and the amplifier can go all the way down to 3 ohms. So the only downside that we get from using an 8 ohm speaker is that we don't get the full power from the amplifier, the Ohm's law. So I'm just going to crank the volume all the way up, and you can hear. And now we are back. So Our power supply is very happy. Even when I've loaded the thing, let's see. So also another cool feature of this power supply, the way it has been made. So at low volume you get around 20 volts at the output, but upon cranking the volume all the way up, the voltage just goes up. That's how this circuit is being controlled.
Watch out, if your enemies are over ahead of don't see to be the greatest beast the world has ever seen. I feed him every day with the blues clean. I feed him all I hate and he goes me. He gets caught real big, pissed off quick. And if you cross him, you might drop dead. Metaphorically, of course, settling the score, never getting bored. That's the blood and gold. Always wanting more, freedom from the source. Can't relieve this in a death. They feel the force of body. And you start shaking, be hard lived in the darkness. Toward a dark way, and scars ripped to be chewed up and discarded. And this world ain't right, won't accept it. Negative energy, I expect it. Once it's in your mind, it's infectious. So fight for your life.
Well, I think I'm done. So what is left here is for me to clean up this thing, you know, the cockroaches, and also after some time I'll go to the market and find a new set of capacitors here. So because these ones need to go, these ones, all the 4 capacitors need to be replaced. See how they are, we call them the pregnant capacitors. Well, I hope this video has brought some light onto how we do such a repair. This was a straightforward repair. Sometimes these issues get complicated, but this one I'll say it was an easy one. Well, subscribe to the channel, and I'll see you next time.
And this world ain't right, won't accept